Giken Power, transforming construction globally. In construction projects, piles play a vital role. They are used, for example, in retaining walls to contain landslips, in cutoff walls to block the seepage of water, and in the foundations of buildings. Pile driving has been revolutionized by a new principle developed by Giken. We call it the press-in principle. Conventional pile driving methods either use percussion to hammer the pile into the ground or vibration to shake it into the ground. Both methods generate construction pollution, which has been a major social problem. By contrast, the press-in method employs hydraulic pressure to install the pile in the ground using a static load, generating no noise or vibration. This, unlike conventional methods, is eco-friendly. Invented by Giken, the silent piler press-in machine is the world's first practical application of the press-in principle. In piling work, this is a revolution in principle. The silent piler grips a previously installed pile, integrating itself with the ground. Using the installed pile's extraction resistance as a reaction force, the silent piler applies a static load to the subsequent pile, jacking it into the ground without vibration or noise. A compressed clod of earth known as a pressure bulb forms at the toe of the pile, giving the pressed-in pile a solid structure both horizontally and vertically. Offering greater eco-friendliness and rationality, the press-in method has been used extensively to build retaining walls and high-quality structures. Conventional construction methods, however, still suffer from a major structural drawback. Typically made of reinforced concrete, this is known as the footing structure. Here at Giken, we advocate a structural revolution, namely switching to the implant structure. On the left, you see an implant structure. On the right, a conventional footing structure. With the implant structure, factory-produced, pre-formed modular components are simply pressed in from above the ground, enabling the foundation and structural elements to be completed at the same time. The footing structure, however, requires an underground foundation that is larger than the structural element, necessitating deep excavation over a wide project site. All sorts of processes are involved, including temporary works. Because the implant structure uses pre-formed modular components, the required performance can be designed in. Let's say the supporting horizontal and vertical load requirement is 10. Through the size of the elements used and the ground penetration depth, the design delivers a total bearing capacity of 10. On site, the press-in process advances, progressively completing the retaining wall in accordance with the design. Should the functional requirements later change, the structure can be dismantled and removed with ease, simply by reversing the construction process. This is because the implant is designed to be a functional structure. The footing, however, is designed to be a permanent structure. Yet mankind's very existence is a mere blip in the Earth's history. Considering the rapid pace at which our science-based civilization has developed, we should not assume that today's society and its values will stay the same forever. To accommodate changes in society over time, structures need to be able to change their function. They need recyclability and a function-driven life cycle based on functional flexibility. First, the functional structure is planned and designed on the assumption that it will one day be dismantled and removed. Optimal equipment and pre-formed modular components are developed and produced in the factory. On-site, piles are pressed in non-stop from above ground, without any temporary works. The structure then begins to fulfill the function for which it was originally designed. Changes in function, such as converting a highway from 2 lanes to 3, are accommodated flexibly. Having fulfilled its function, the structure is dismantled and removed, restoring the environment to its original state. As a rule, the removed structures and materials are reused. At the next planning and design stage, they are adapted to another location or to different conditions. Despite being used for the same structural applications, the implant structure and the footing structure are completely different in terms of the work involved. An objective numerical evaluation using the 5 construction principles makes the difference clear. Giken is spearheading a construction revolution to help every construction project obey the 5 construction principles. These provide universal criteria for evaluating construction projects from the viewpoint of the general public. The 5 requirements are environmental protection, safety, speed, economy, and aesthetics. Together, they form a harmonious pentagon. Thanks to the superiority of the press-in principle, Giken has achieved a groundbreaking construction system eliminating the need for temporary works. The Giken Reaction Base, or GRB system, which utilizes reaction force, enables all the processes, pile transportation, pitching and pressing in, to be completed without the need for temporary works by working on top of the installed piles. Its benefits become dramatically apparent in the field of disaster preparedness. Using the GRB system, basic construction goals can be achieved, upholding the 5 construction principles, even in situations inaccessible to conventional construction machinery. In projects where human life and property is protected from natural disasters by the rescue method or the guard method, the GRB system has an especially large role to play. These days, many aging buildings are undergoing functional regeneration or seismic strengthening, or having their functions enhanced to accommodate growth and development. For urban renewal projects like these, the increasingly complex city environment presents major challenges. Thanks to the outstanding environmental protection and safety provided by the press-in principle, construction works can now be carried out close to railway tracks and buildings, even during daylight hours, without disrupting rail travel. Usually, when a bridge needs to be replaced or seismically strengthened, the old bridge is removed and a temporary diversion is set up, enabling the works to be completed while preserving the bridge function and the existing traffic access. Without removing the foundation of the existing structure or any underground obstacles, functional enhancement is conducted from above ground using gyro press cutting. Driven by our construction revolution, Giken's new construction method is upholding the 5 construction principles in over 30 countries. Giken advocates the adoption of implant structures to develop new urban parking systems. Known as the eco-park and the eco-cycle, these parking systems are based on a concept we call culture above ground, function underground. The functional element of vehicle parking is neatly stowed underground, freeing up the above-ground space for cultural activities. Conceptually and technologically ahead of the curve, the eco-park and the eco-cycle preserve the elegance of the cityscape while offering the amenity of parking. The vertical development built over an eco-park foundation has already become a reality. Giken's construction revolution is underpinned by empirical science, which combines theory with practice. By measuring the behavior of the hydraulically controlled installed piles in real time, thus making visible what lies unseen underground, the structure can be subjected to scientific quality control. With this end in view, in 1994, Giken joined forces with Cambridge University in the UK to launch a collaborative research program on the press-in principle. To date, 3 of those involved have become doctors of engineering specializing in press-in technology. In 2007, the International Press-in Association was founded. It now promotes press-in engineering, the scientific study of the press-in method on a global scale. Empirical science, which does not rely on intuition or experience, is the driving force behind Giken's construction revolution. Through its own inventiveness, Giken has exploited the advantages of the Prescience principle in practical applications, developing new technologies and construction techniques obeying the 5 construction principles. Having translated this hands-on experience into a rich store of practical knowledge, Giken continues to lead the global Prescience industry in expertise as well as hardware. Possessing an infinite capacity for development based on empirical science, Giken is committed to the use of implants to create functional structures. This all-around ability, the mindset and the technical skill to harness our unique creativity in the service of a construction revolution is what we call Giken Power. Using Giken Power, we intend to transform construction on a global basis.